Hello and welcome to this tutorial. My name is Matthew Thompson, and today we're going to cover how to speak to your iOS chat app. I built APZ8, a free journal app for your iPhone. It asks you questions, celebrates your accomplishments, generates AI art, and you can try it from the link in the description. So to complete this tutorial, we're going to need to cover SwiftUI, Firebase Python functions, and Firebase storage. And we will need to use Google Cloud Speech API to listen and speak to the user. So the end result of this tutorial will be that we have a new button here in the chat app. And when we click on it, it will record our voice and show a nice waveform here of the recording.
Great, because my voice has been practicing its surfing skills and it's ready to ride the wave. Form.
It will transcribe what I said and make a joke response.
Well, I hope it has a good sense of humor because my last transcription dated my handwriting and said, "It's not you, it's your cursive."
And it will play the response to the speaker and show the waveform of the response.
So now my voice gets its own roller coaster ride? Hold on to your syllables, we're about to drop the bass.
And hopefully this will result in a couple laughs for you once you have it all working.
A couple laps? I just hope my punchlines don't get too dizzy and start throwing up punch.
Awesome. Let's go over the design needed to speak to our iOS app. I've broken it into three major sections. We have the iOS app running here. We have the Firebase Cloud Functions running here. And we have AI APIs over here. And we also have the Firebase interface here. In order to navigate this design, we're going to need a legend. Our legend here is going to show that listening is going to be in red. Speaking is going to be in blue. Audio will be solid lines, and text will be dotted lines or dashes. Now, one problem with this, looking at this design, is it's rather complex. So let's go ahead and break it in half. And so first we're going to cover transcription, which is listening, and then we'll cover synthesis, which is speaking. So let's go ahead and talk about listening or transcription. So here in the iOS app, we can start by listening to the microphone from the voice view model. The voice view model will take the audio levels from the microphone and put it into a file. This file, it will then store into Firebase storage for that account. Once it's added into the Firebase storage for the account, there will be an onObject finalized trigger within the Cloud function that will activate when the file is completely loaded into the storage. Within the main.py that we developed in the previous tutorial, we're going to have a new file function. And this new file function will take the file and it will pass it to speech.py, which will then call the Google Speech API to transcribe the audio. Once it's transcribed the audio, it will return a text string of what the person said. This text string will then be passed from speech.py back to new file, and then the text will be passed to account.py to create a new message for the account, and then account.py will pass it into the Firestore database. So this is how we're taking the audio levels from the microphone and turning it into a new message in the chat in text format. So that's listening or transcription. Now let's cover speaking or synthesis. Now that we've listened to the person speak, we want to respond to them. It's like everything but in reverse. So we're going to start from the Firestore database and we're going to trigger on document created. So when that new message was created, when we listened, this trigger will activate and start generating a response. So the on document created will be triggered and it will carry the text of the message that the user spoke to the system. This will trigger the new message function. The new message function will then call the comedian.py from the previous tutorial, and that will generate a response from OpenAI GPT-4. This response will then be passed off to speech.py. Speech.py will pass it off to Google Speech, it will pass the text that we want to turn into audio to Google Speech, and then Google Speech will return a audio file of a robot pretty much speaking. This audio file will then come back to new message, and it will be stored by account.py into Firebase storage as a file. Once it's stored in Firebase storage, message view model will pick it up and it will pass it off to voice view model, which will then play the audio on the speaker. So you can see here, what we're doing is we're taking the text from the Firestore database of what the person said, and we're turning it into an audio file of the comedian saying something back. And so if we look at the overall system and return to the overall design, you can see that we're reusing components. So we're reusing the speech.py for both the transcription and synthesis, and we're reusing account.py for both the transcription and the synthesis. The design goals here are for it to be secure. So the way that we're making it secure is that we're using Firebase storage and Firestore database as the interface between the iOS app and our cloud functions. So that provides a relatively secure interface provided by Google. We aren't dealing with things like ports or firewalls or anything like that. All of our functions just speak with these Google provided components. It's designed to be scalable. What we mean by that is that you could have, let's say, one iOS mobile app here, or you could have perhaps 10 million. And this design would not necessarily need to change. If 10 million iOS apps were connecting to Firebase storage is designed to scale, or at least Google says it's designed to scale. And then on object finalize would be called 10 million times. So new file, the Firebase function would scale up 10 million times. And then it would call these AI APIs 10 million times. And they're also designed to scale. So everything here is either provided by Google or OpenAI and designed to scale. And then everything here is on the Apple devices. So it should, in theory, scale almost infinitely to the limits of Google and OpenAI, which they have thousands of developers. And in our case, you probably have one or two developers. It's really nice to build on the shoulders of giants. It's efficient. The everything here is really quick. None of the processing is happening in our cloud function. It's all happening by Google and OpenAI. So that means that just like the security, everything is as efficient as Google and OpenAI can develop. We're doing no math here or anything. We're really just passing files. And one thing is, in here, we're not even passing the file. So on object finalized, when we pass it to Google Speech, we're just passing the path to the speech file or the audio file. We're not even passing the audio file. So we're not even transferring the data in this cloud function. When we do transfer the data for the Google Cloud Speech API response, so when it does respond with the audio file, we do get the actual bits and bytes of the audio. But I don't see a way to tell Google Cloud Speech API to store in a bucket, then we're storing it in a bucket ourselves. It's extensible. We designed it so that the Firebase function here, the new file, does not do any of the real work. Speech.py does all the speech functionality. And that means that if we wanted to change out Google Cloud Speech for any other AI provider, all we would have to do, in theory, is change the speech.py. And our other functionality here would not need to change, and especially back here, we would not need to change anything else but the speech.py. Furthermore, if we wanted to change our chat agent, so if we want to change out ChatGPT for some other chat GPT, we could, and all we would need to change in theory is comedian.py. And finally, if we wanted to change our storage system, so our interface here, which passes the messages and the audio files, we would only need to, in theory, change account.py. However, our cloud function may change the way we run cloud functions. But the idea here in general is to be able to move the application to whatever solution is best at the time. So if there's a better speech product, we can switch it out to that. And that's how it's extensible, is that you can connect it to various different things. Before we begin this tutorial, let's go over what you'll need to have set up in order to follow along successfully. So the first thing that you'll need to have is the previous tutorials completed. So the first tutorial, we covered how to send messages and that video title is called How to Create an iOS Chat App. The second tutorial is called How to Make Your iOS Chat App Respond with GPT, and that tutorial covered how to make the app respond to you using ChatGPT's API. And so you'll need both of those tutorials completed in order to build off of it with this tutorial. Next, you'll have to make sure that Firebase storage is set up and enabled. And then after you've enabled this API, you're going to want to make sure that Cloud Text-to-Speech API is enabled within your Google Cloud Console. After you've enabled Cloud Text-to-Speech, you're finally going to want to enable Cloud Speech-to-Text API. And so these are the APIs that will be performing all of the AI heavy lifting for converting speech to text and text to speech. And that's it. And we should be able to begin coding. Before we start speaking to our iOS app, let's first just make a couple quick changes that'll make the app look a little bit nicer. So we're going to do let min length equals 30.0. We make the min length equal to the min length. So this will make it so that the chat boxes are better arranged. For the colors here, we're going to say, so what this does is it'll make it a different color if it's not the author, and it will also, we're also adding a minimum spacing on the spacer so that it should look a little bit better, and we'll try it out. And now the bubbles have a slightly better appearance. And then what we're also going to do is we're going to create groups in our project for account and move our account stuff into there. And we're going to make one for message so that everything's a little bit nicer and contained. If we want to be able to speak to our iOS app, we're going to need to first record audio from the microphone and store the recorded audio file into Firebase storage. So to do that, we're going to be creating the voice view model and a couple other useful files for user interaction. So here we have the project, and we're first going to create a new group, and we're going to call it voice. And within voice, we're going to create a new file, and we're going to create a Swift file. And it's going to be called voice view model. And so this will manage everything to do with the audio. Within here, we're going to do a couple imports. And in this case, we're going to import AV Foundation, which is going to handle our audio things, and Firebase Storage, which is where we're going to store the resultant audio file. So next, we're going to create a class called the voice view model, and it's going to be of type observable object. And then we are going to initialize the Firebase storage. So that's going to give us a handle to be able to store the files. After that, we're going to define a session for the audio session, and it's a shared instance. You can only do this once within your project, so it's kind of challenging. You can't really have a class for the recorder and a class for the player of audio. You have to kind of put it all in one place, which is not really nice. Then we're going to define the recorder, and it's an optional type. So it can either exist or not exist, and that's defined by this question mark. Then we're going to define the path. So this is a URL to the audio file that we are currently recording, and we need to keep a record of that so that we can then pass it off to Firebase storage. And then we have a recording ID, which is just a unique identifier that we're going to generate for the recording so that we don't overwrite our file. We're going to then define a couple state variables. So these are published. So as they change, we can have user interface things updating based on them. First is the upload level. So when we go to upload the file to Firebase, this level will go between 0 and 1 based on how much the file is uploaded into Firebase. Then we have the is recording Boolean. So currently it's set as false, but what it's going to do is it's going to represent whether or not we are recording. And finally, we have the audio level, which is how loud the audio is at any point in time. After this, we're going to define the initializer. So this initializer will run just once when we create an object for this class. Within this, we're going to try to set a couple boilerplate things for the session. So it's kind of challenging to describe what's happening here because it's just some SwiftUI boilerplate stuff. But pretty much what we're saying is we want to be able to play and record off this session. And we are also going to allow Bluetooth and default to speakers. So this is great for the iPhone. So if you have an app and you want to be able to record and play audio, sometimes what it will do is it won't play it to the Bluetooth device. And that's kind of a pain. And also when you're using this app, we want it to play out of the speaker, not just like the small little speaker on the phone, because we want it to like project the voice out to the user. And we kind of have a poor error handling here where we do and catch and print error. That's an anti-pattern, but in this case we haven't yet built in a nice error reporting system, like for example Sentry, where we can catch all the errors and deal with them. And we don't really have an error state in the app yet. It's kind of too basic for that, but you could have like an error page saying, oh, something went wrong. Okay, so after this, we're going to define a function called start recording. And what this function will do is when we click the recording button, it's going to call this function. And we actually want to start the process of recording. Within here, we're going to have a do catch. Additionally, anti-pattern, don't do this, but do this at first and then improve it. So within here, we're going to define, we're going to get access to a temporary directory URL. So what this is in Swift and in iOS development, you have a couple different directory types that you can use. You can use, I think, a cache directory, a documents directory, and in this case, temporary directory. So what this does is we're going to save the audio file into this temporary directory URL, and we don't really have to worry about cleaning it up or anything because it will automatically be cleaned up because it's temporary. And then we're going to save the file into there. So next we have a recording ID. So this will be the ID of this recording. Then we'll have a temporary file name, which is just the recording ID plus .wav. And so we're going to be saving into the format of .wav. That just seems like the way that that iOS and Swift save files. Then we're going to create a path. So the path is going to be the path to the recording, and we're going to take the temporary directory URL, and we're going to append the path component, which is the temporary file name. So we're just kind of building up that path. Then we're going to define the recorder. So the recorder is going to be of type AV audio recorder, and it will record audio for this when you click on it, and it will save it into the path. So that's kind of what's happening, and we don't have any settings. Next, what we want to do is we want to set metering enabled. So what metering enabled does is it allows the recorder to have a meter or a audio level that changes as the person speaks. And so that's how we can get a nice visual going. And then finally, we're going to say, okay, recorder record, and we're going to set is recording to true. So that's the start recording function. And then we're going to need a stop recording function. So here we go. And So here's our stop recording function, and it's going to accept a parameter of account ID. And so that's going to allow us to put the file in the right spot. And then within here, we're just going to say recorder stop and set it to nil. So stop recording things and also just clear it. And then is recording is false, audio level, clear that, set to 0. And then what we're going to do is we're going to have a if statement so if we have a recording ID, so because it's optional, we have to kind of say that. And then we're going to create a reference to the storage. So this gives us kind of an access to the root of the storage in Firebase. And then we're going to say, okay, let ref equals storage ref.child. And then we're going to define the path within Firebase storage. So in this case, we're going to design this Firebase storage almost exactly like we designed the Firebase database in the previous tutorials, where it's going to be account/account ID /message/message ID. And then we're going to always have the file named and call it author.wav. So this right now, what we're doing really is we're loading up the file into the cloud. So then we're going to create an upload task. So this task will keep track of the upload into the cloud. And we're saying, okay, this ref, so we're going to upload into this reference and from path. So this is uploading the file into this address from this address, pretty much from this address right here. Okay, and then we're going to, on this task, we're going to observe it and specifically the progress of it. So we're going to observe the progress of this upload task, and every snapshot that we get, we're going to update our upload level, and we're just checking the progress is fractional completed. And if we don't have fractional completed, we're just going to default to 0. And then finally, we're going to observe its completion. So on its success, we're going to set the upload level to 0. Okay. And then finally, we're going to define one more function, and it's going to be, so these are all the functions that we need to record audio. So we're going to have an update audio levels function. And what this will do is it will give us the functionality needed to have like a little meter that shows the sound volume. It's nice to know that you're being listened to, kind of. So that's the idea behind this, is it helps the user feel like they're being listened to rather than just staring at a screen that's just kind of just sitting there. So we're going to check if we have an audio recorder. So sometimes we may not have an audio recorder, and we're going to update the meters for the recorder. And then after that, what we're going to do is we're going to have a little function here, or a little bit of functionality here, which is going to set the audio level to either the maximum of 0.2 or all of this, and then divide by 50. So I found this online, this like formula. So I recommend using it because it kind of works. But it's pretty much just going to make everything scaled correctly. Okay, so that is our voice view model. Now that we've created the voice view model, let's create a waveform view model. So we're going to create a new group called waveform. And within this group, we're going to create a new file called waveform view model. And so what this waveform is really going to be about is it's going to be about showing the audio levels of the recording so that the user feels like they're being listened to. And that's really important because otherwise it kind of just seems like they're talking to like a button. So within this waveform view model, we're going to create the observable object. And so this will represent all the kind of backend for the waveform view model. Within this, we're going to define two variables. So first, the size. This is just going to be the constant amount of bars within the waveform view, and so it's the values. And then we have the published variable called wave, which will be an array of doubles, and we'll initialize it to be empty. And so what that will represent is all the values within the waveform. And then we're going to define one function, which is going to be called update. And it's going to accept the value, a value which is a double. So every single clock tick, we're going to retrieve the current audio levels, and then we're going to call this update function. And within it, first what we're going to do is we're going to say if wave count is equal to size. So if it's kind of full, if this wave is full, we're going to remove the first double within the array. And that will clear out the oldest value. And what we're really creating is a FIFO, a first in, first out. And then we will always append the value to the wave. So this pretty much just keeps the wave at the constant size of 16 or less. And it will update it and let it kind of flow as you speak to it. Okay, next let's create the waveform view. So let's create the Swift file, which is called waveform view. So this will be a little bit more complicated than the view model. So first we're going to import SwiftUI, and then we're going to create the struct waveform view. It's of type view. Excellent. And we're going to define three different variables at the top. So first we have the view model, which is what we just defined. So it's the waveform view model. Then we're going to have a Boolean, which is the author, whether or not this waveform is representing the author speaking, or is it the robot speaking, or the comedian. And then finally we have the width. So this is going to be the width of the bars. And we're leaving that as constant right now. So within here, we're going to have to define a body, otherwise Swift complains. And it's still going to complain. We're going to create a H stack within this. And the spacing is going to be the width divided by 2. So we have the bar width, which is, let's say, imagine if it was 4. Then the spacing, we're going to make it 2. So it's kind of a nice 2-to-1 ratio between the spacing and the width of the bars. And then within this, we're going to create, and this is kind of a little bit complicated. So we're going to run a for each for all of the wave indices. So for each, so imagine if we have a wave of, let's say, list 20, so 20 values in the wave. Then we're going to have, this creates an iterator over all the indices. So it would be 0 to 19. And then the ID will be the self. So this gives us kind of the index within the wave, and it kind of iterates over all of the indexes within the wave. And the nice thing about this is you need to do this for Swift to like dynamically move things around. You need to give it an ID for each of the elements, each of the bars. And so in this case, we're using the index. We're not using the values. So imagine if the wave was of values 1, 2, 3, 4, 5, 0.5 or something like that. We're not using the values because they may not be unique. So for each one of the indexes, we're going to create a rounded rectangle, and the corner radius will be the width divided by 2. So that kind of creates a nice like pill shape effectively. And then we're going to fill it with a color, and the color will be dependent on whether or not it's from the author. So if it is coming from the author, we're going to be making it in the color green. And if it's not coming from the author, we're going to make it blue. So this kind of differentiates the waveform of being from the kind of robot or the comedian or from the user. Finally, we're going to create a frame around this rounded rectangle, which will define its size. And the frame will be of width, which we define up here. And the height will be the actual value of the wave at that point. So it's actually kind of like the audio level. And we're multiplying that by 60 pixels to give us a little bit of height to the waveform. Now, one kind of interesting thing is we're going to actually duplicate this. So we're going to do pretty much copy paste the same thing, except for we're going to reverse the indices. So this gives us a flipped image of the waveform, and everything else is pretty much the same. Now, you could do this better by not duplicating the code, and I'd recommend doing that better. But in this case, it's kind of just simple, just to copy paste it, add reversed. The problem with that is, imagine you're changing the corner radius from this to, like, let's say 3. Now you've got a bug because you didn't change this one. So that's why code duplication isn't quite nice. But in this case, let's just throw it in. And then we're going to apply a quite complicated mask to this whole thing. So within the H stack, we're going to apply a mask to it. And so what this mask is going to do is it's a rectangle, and its fill is a linear gradient, and the gradient colors are clear, black, black, clear. So the idea is that what it's going to do is it's a mask, and it's going to allow, the black is what it allows. So it's going to allow the center, and then it's going to fade out to the edges. And that's what's going to give us that nice waveform that seems like it's fading off into the distance. And so its start point is going to be leading, and its end point is going to be trailing. Quite simple. But yeah, what this really does is it masks the waveform and fades out the outer edges, but keeps the center. Okay, so that's our waveform view. So now that we have the waveform view, the voice view model, and the waveform view model, what we need is the voice view. So this will tie everything together. So we're going to create a new Swift file, and it will be voice view. Okay, and within our voice view, we're going to need two things, which are the SwiftUI and Firebase Firestore. And then within this, we're going to create a struct, which is the view. And we're going to need a couple variables here, actually 5 of them. So first, we're going to have the parameter, which is the document reference, to the account reference. So the first one is the reference to the account document for this kind of user. So that lets like further down modules to have access to the account. Next, we're going to be observing the message view model. So this message view model, we kind of created in previous tutorials, but it kind of accesses all the messages in the chat. Next, we have the wave view model, which we created, and the voice view model, which we also created. And so those are all state objects. So that this is like kind of defining them and keeping them at this level. And then we have a timer. So we're defining a timer, and this timer will publish every 0.1 seconds, or 10 times a second. And what that will do is we're going to use it to check the audio levels and add a new bar to the wave, to the waveform, 10 times a second. Okay, so within here, we're going to define the body. And within this body, we're going to have an H stack with a spacer. So this is creating a horizontal stack, and we're moving everything to the right by creating a spacer at the start of it. And now we're going to say if we're recording. So the voice view model keeps track of whether or not it's recording. And if we are recording, we're going to want to show the waveform view. And so the waveform view is going to need to have the wave view model. And it's also going to need to know if it's the author that we're presenting this waveform for. And then what we're going to want to do is we're going to create an event and on receive. So if we have the waveform view, we're going to want to have the timer update the audio levels. So voice view model update audio levels, that will grab the audio level, the current audio level of the recording. And then what we're going to do is we're going to say update the wave view model, and we're going to take the voice view model dot audio level from the voice view model. So this will take the audio level and pass it to the waveform so it can update and show the kind of wave of audio going across. After this, we're going to add a spacer. So that spacer is going to keep this waveform in the middle. Let's see here. Oh, no, sorry. We're not going to create there. We're going to create here. And our code is kind of gotten out of hand. So what we can do is we can say editor structure read indent, and that will correct things to make it more obvious where I should be putting this spacer. Okay, so after this, we are going to say if. So here we're going to create a progress view. So we're saying if the voice view model upload level doesn't equal 0. So if we are uploading, show a progress view, and the value of this progress view will be the voice view model dot upload level. So this will give us a progress bar showing us the audio being uploaded. And it's pretty much just that simple. And then next we're going to create a button. So this button will be to start the recording. And this button will look like this. So pretty much, yeah, don't worry about that error. But the action for this button will be voice view model. So if the button, the action of this button is dependent on whether or not we're recording or not. So it's either going to start recording or it's going to stop recording. So if we are recording, then stop recording. But if we are not recording, start recording. So that's kind of how that works. And then what we're going to do is we're going to create the actual label for the button. So here we define the label. And the label is going to be an image of the microphone system name. So these are the icons that you can find in the SF icons app. So pretty much there's a bunch of icons that SwiftUI comes pre-packed with. And I'm just going to be using them, or we're just going to be using the microphone one. And we're going to make it resizable, scaled to fit. And then we're going to define a frame around it, which is 64 pixels by 64 pixels, which makes it like a reasonable button to click. Okay. And then finally, what we're going to do is we're going to say that everything within here, we want the foreground style to either be red or green based on whether or not the voice view model is recording. So if we're recording, let's make everything red. If we're not recording, we're going to make everything green. And so that applies to everything inside. Specifically, we're thinking about this microphone image. All right. So now that we have the voice view, we are going to want to tie everything in by connecting the voice view to the account view. So we haven't really plumbed everything in yet. So here we have the scroll view. And just below the scroll view, let's add this voice view. Okay, so now we can kind of give it a shot and try it out. So one thing to consider is that we're going to want to enable the storage for this project. And within Firebase storage for this project, we're going to want to set the rules for storage. And what I've done for this, for the rules, is I'm matching so for service firebase.storage, we're going to match the bucket. I'm not sure what that does actually, that first line. But specifically, we're going to match account / user ID / all paths. And we're going to allow read write if request.auth doesn't equal null. So what that means is we're going to check the authorization for the request. And if the user ID for the request's auth is equal to the account / user ID, so it's if the user ID matches the directory path, then we allow it. Otherwise, don't. So this pretty much will force the accounts to stay within their accounts and stay within their zones. And so you're going to want to enable storage and then also specify this rule so that we can store the audio files. So now that we've got the project running, let's give it a try and try to record our voice and see if we can have the voice appear in the Firebase storage. And so we will click record, and you can see the audio voice levels. And it's generally quite high because my Mac's going nuts, but let's see if it creates the file. So now we can refresh this page and we'll see that the account directory is created. And then this is the user of this simulator. And then we have a message, and then we have a unique ID, and then we have the author.wav, and we can actually download it. So let's try to download it right now. Open. And you can see the audio voice levels. And it's generally quite high because my Mac's going nuts, but let's see if it creates the file. And so there you can see that it actually did record my voice at least through the simulator, and it saved the file into Firebase storage. So if we go back to our design here, we have recorded the audio on the microphone, saved it to a file using the voice view model, and stored it into Firebase storage. And so next, what we're going to want to do is we're going to take on object finalized for this file, and then we're going to want to send it off to Google Speech and then create a new message based on it. So now that we've recorded the audio and stored it into a file and then placed it into Firebase storage, we can work on taking this audio file and turning it into text. And we'll do that by passing it to Google Speech. And then what we'll want to do is we'll want to create a new message for this text so that it acts just like the account or the user typed in the message, but instead they spoke to the app. So let's go ahead and write the main.py new file. Then we're going to also write the speech.py and account.py. We're going to add a new functionality to set a message. Okay. So here is the project at the state of the previous tutorial. First, what we're going to want to do is we're going to want to open up requirements.txt, and we are going to add cloud speech and cloud text to speech. And I'm just checking to make sure that the audio is working, because that is important. Check, check, check. Okay, now that I've added the Google Cloud Speech and Text to Speech to the requirements.txt, we're going to want to create a new class within our project, and it's going to be speech, and we're going to be storing everything in there. Now that we've added Google Cloud Speech to requirements.txt, we're going to create a file to work with this API. We're going to call it speech, and we're going to add it to Git. And so within this speech, we're going to import speech v2 from Google Cloud and text to speech. And we're also going to use OS. We're going to get the project ID from the environment variable gcloud project. So this allows us to know the string, which is the project ID. Then we're going to define the class speech. Within this class, we're going to have an initializer. This initializer will initialize the speech client. Then we're going to define a function called listen. So this listen function will accept a Google Cloud URI. And so what we're going to do is we're going to take a URI or a path to a storage object within Google Cloud or Firebase storage. And we're going to run speech v2 transcription on it. And so first what we're going to need to do is we're going to want to need to create a configuration. And there's quite a bit of boilerplate that's involved with this speech recognition stuff. And to be honest, it's difficult to understand exactly what is happening here. But pretty much what we're doing is we're creating a speech recognition configuration. And we're just going to auto detect a decoding configuration for the audio file. We're going to specify the language code, which I assume is the language that we will be interpreting for the speech. If you wanted to create this for a different language, you can look at the speech v2 supported languages and choose yours. We're going to choose the long model, which allows it to really process the a longer paragraph of talking. And then finally, we're going to define the features for this configuration. And the features, we're going to enable automatic punctuation. And so this is really important so that as the person speaks and they pause, it will automatically add a period or comma. And so that's kind of nice for creating something that looks like they typed it out, but they actually just spoke it. Okay, so now that we have the configuration of this recognition, we are going to define the request. So this request, you have to specify a recognizer. And for this, it's kind of weird, but Google Cloud Speech Recognition has the concept of recognizers. But in this case, we don't have a recognizer, but we still have to define it. It's this weird thing that I think the API just needs a little bit of polishing. But we'll also specify that we're going to be using the configuration that we defined above. And we're also going to specify that we're using the URI of this file. So that this URI tells the speech recognition, hey, this is the path to this audio file. So transcribe it. Okay, so now that we've created the request, we are going to pull the response out of the request. So first we're going to just define an empty string called text, and then we're going to iterate over the recognize results. So it produces multiple results, and for every result we're just going to append it to text. And so it kind of has like a bit of like a generator situation happening. So if you had like a really long audio file, then maybe you may want to just slowly go through it and pull out chunks. But in this case, we're going to assume that you're only talking to it for a couple seconds. So we can just unpack it all here and then return it when we're done. Okay, so that's the speech.py, or at least the start of speech.py. This is the listen function, but eventually we're going to define the speak function. Next, what we're going to want to do is we're going to add to our account.py, we're going to add the ability to set a message. So previously we had the ability to create a message from not the author, but now we're creating a message from the author. So we're going to define it like this. So pretty much this set message accepts a key, which is the address of the document. It accepts the text and it accepts the author. So it says, okay, just create a new message pretty much, but instead of creating a new message just with not specifying the key, we're going to specify the key. And we can also choose the author. Okay, so, and this is needed because we're going to be creating a new message right here. So you can see in our design, in our new file, when we're done creating, transcribing the audio, we're going to want to create a new message and pass it through. And so that's why this is necessary. Okay, so we're going to go back to main.py. So now we're going to tie in everything together. So now we have the ability to transcribe speech. We're going to add a couple imports at the top first. So we're going to add, here we're going to add storage function. So this gives us access to the storage functionality. And then we're going to need speech. So some speech, import speech. And we're also going to want pathlib. We'll be using this soon. Okay. So next, what I'm going to be doing is actually, for me, it's actually US East 4. Make sure your regions are correct. So I'm going to create a storage function on object finalized. And so this will trigger when the audio file, a new audio file is added to the storage bucket. And so we're going to define the cloud function, and it's going to be called new file. Not very creative. First, what we're going to do is we're going to parse out the account ID. And so because we used our path, we encoded our account ID into the path, we can pull it out here. And we also encoded the message ID into the path. If you remember when we created the audio file. And then we have the overall file path to the file. So with this information, we can create an account. So this is the path to the file, by the way, in Firebase Storage. So now we can create an account. So we have this like account class, and we create it if we have an account ID. And so in this case, our account ID, we're getting it from the path of the audio file. So then from this, we can get the URI of the audio file. So it is, to do this, so pretty much what we're doing is we're crafting a URI for the cloud speech to pull the file. So we're creating an address, and so to do that, we have to specify GS, which I think is Google Storage, and then we specify the bucket, so the Google Storage bucket, and then the file name, and that should point Google Cloud Speech API to the storage. So this Cloud Speech is actually connecting straight to the storage. Okay, so now that we have the URI, we're going to check to see if this is a message from the author. So in the future, what we're going to be adding other files to the cloud storage, and we don't want to transcribe every audio. We just want to transcribe the audio files from the author. And so once we know that we have an audio file from the author, we're going to listen to the file. So we're using the speech API that we created before, and we are listening to the audio file and generating a text. And once we have the text, we can go ahead and create a new message. So we're going to set message, and the message ID will be the message ID that is stored in the path of the file. And then the text we're going to pass into the set message, and we're specifying that this is from the author. So we've transcribed the audio and we are setting the message. So let's go ahead and run this. So we are now deploying these new functions to Firebase Functions. Now that the Firebase functions have been deployed, let's give it a test and see if we can transcribe the audio. So I'm going to go ahead and click here. What it will do is it will record the audio, save it to the device, upload it to Firebase storage, trigger the Firebase function, transcribe the audio, and hopefully create a new message. And when a new message is created, the existing comedian should respond. Hello, this is a test. As you can see, the waveform is kind of nice, how it fades out to the sides. And look at that, it transcribed the audio almost perfectly. Yes, indeed. It's got more fade than my uncle's hairline at a family reunion. That's pretty funny. Okay, cool. So we have transcription handled. And so we have audio being recorded on the microphone, passed by the voice view model to Firebase storage. That triggers the Firebase function, which is called new file. That then calls speech.py listen. Speech.py passes it off to Google Speech. The text comes back and we create a new message, and then all of the previous logic is running. So that is listening and transcription. So now that we have transcription handled, or listening, we can now build up the speaking or synthesis. Previously we started on the iOS side, or Swift, but for speaking and synthesis, we will begin on the Python or Cloud Function side. We are going to start by adding the ability for speech.py to generate a audio file. We're going to take that audio file and store it into account.py, and we're going to trigger creating that audio file based on when a new document is created. So let's generate audio for the comedian and play it on the speaker. So the first thing that we're going to do is add the ability for the speech module to speak. So we have a method for listening, and now we will add a method for speaking. So that will actually just look like this. And this speak naturally takes text, which will be a string. So we're going to create a client within this module or method, and this is a text to speech client. And then we will define a input to the client. So this is, we're going to call that synthesis input, and it will be a text to speech synthesis input and provide the text to it. Next, we're going to define the voice. So for the voice, we are going to specify English, American, gender neutral. And so you can see, yeah, voice selection parameters, language code, American, neutral gender. Okay, so after we've defined the voice, we're going to configure the audio. And we're going to say that we want the audio to be encoded as an MP3. Pretty straightforward, pretty common format for audio. And then we are going to synthesize. So we're going to say response is equal to client.synthesize speech. And we're going to say that the input is the synthesis input, the voice is the voice, and the audio config is the audio config. And finally, this method will return the actual bytes of the response. And it's just that simple. Next, now that we have the audio content or the bytes for the audio, we're going to want to store these bytes into Firestore. So we're going to do that in account.py. So we're going to add in a new method, which is going to be called store audio. And so what store audio is going to do is you're going to have to pass it the message ID for this audio, as well as the audio itself. You're going to have to specify the bucket. Sorry, you're not going to specify the bucket. We're going to create a bucket, but first we need storage. So we're going to get storage from Firestore admin. There we go. So we have the bucket, and we're going to say the path is equal to the message path / the message ID. And we're going to save the file as robot.mp3. And so then we're going to create a blob So based on the path. So we're defining a blob in the bucket with the path, message path slash message ID. And then we're going to upload from string. So the audio is in string format, and we're going to upload to the blob. Now, one thing is we need to define self.messagePath. So we're going to define that in the initializer and say self message path is equal to the account slash the account ID slash the message. So this pretty much just takes the audio file as a string and uploads it as a blob to the bucket for this account. Okay, and now we're going to need a second function or second method, and that will be complete audio. So what complete audio is going to do is it's going to accept the message ID that we're completing and the audio path. And then what it's going to do is it's going to take the message document, which currently usually has the fields time, text, and author. You can see here, this is the normal message document. We're going to add a new field, and it's going to be called audio. And the audio is actually going to be a path pointer to the audio file in Google Cloud Storage. And so what this does is when the audio file is done uploading into storage, we're going to complete it. And we can do that right now by going into the main. And if you remember, we had this if statement. And so we're going to add another if statement. And we're going to say else if file path matches. So if it's the robot.mp3 that we just had from here, so if it's one of the audio files from the robot, then complete the audio for this message. So that's going to save the path to the audio file in the message document. And so this will trigger once the store audio has completed. And so the idea behind this is that we want to wait until after the storage, after the file is completely uploaded. That's when we'll say, okay, in this document, in this message document, the audio is ready for download. Okay, now what we're going to do is we're going to actually generate the audio and speak. So what we're going to do here is say, okay, account.newMessage. We're actually going to say joke ID is equal to new message. So we're going to want to get the joke ID. We're going to return, when we add this, we're going to return this at one.id. So the add method returns a tuple, and if you get the second one and the ID property of that, you can get the ID of the document that was just created. That's kind of handy. And then, so now that we have the joke ID, we are going to say, okay, audio is equal to speech dot speak the joke. So now we have the audio as a string, and we've generated the audio. And now what we're going to do is we're going to say account dot store audio, and we're going to pass the joke ID and the audio. So pretty much when we're generating new jokes, we're also going to generate the text for the joke. Oh, and speak needs, yeah. Oh, we need to initialize or create the object. Okay, so we can try this out now and see if we are generating audio files for the comedian's responses. So let's deploy the functions and see if they work. Now that the cloud function has been deployed, we can test it. I wonder if you can speak now. I'm going to check the files. So within this account, we're going to see audio. So now let's go ahead and download it and see what it sounds like. Okay, so downloaded the audio file. Let's play it.
Sure, but if my voice is missing from the files, just remember I'm not the one who forgot to save the holiday photos last year, Karen.
And there you have it. It played the audio for the joke. So it's able to now generate the joke audio. And so what we've just done now is we've triggered on document created. We will trigger the new message. The new message will create a joke. Then it will take that joke and then it will pass it to speech.py, pass it to Google Cloud Speech API, which will return an audio file. And that audio file we then pass through account.py into Firebase storage. So that is the backend part of generating audio for jokes. All right, so now that we have the listening and the back end of the speaking handled, we want to develop the iOS side of the speaking or synthesis. So we can take the file that was added to Firebase storage and play it through the speaker. So first, we'll be changing the message view model so that it can listen to the Firebase database for the message document to have a audio field added. And then what it will do is it will download the audio file from Firebase storage and then pass it on to the voice view model. And the voice view model will actually play it through the speaker of the iPhone. Okay, so let's skip over to the code. And so first we are going to work on this message view model. And what we're going to do first is we're going to actually import Firebase storage, because Firebase storage is how we're going to work with the audio file and collect it. Then what we're going to do is we're going to add a new field to our message document, which is the audio field, and we'll make it an optional string so it can either be there or not. After that, we're going to add to our message view model the audio listener. So what the audio listener is going to do is it's going to keep track of a listener registration just so it doesn't get deallocated, and so that it will keep listening for new files, new audio files. Then we're going to define the storage. So this is just a handle to the Firebase storage. And then finally, we're going to add this very large function, which is necessary, but honestly quite brutal. So I'm going to describe line by line how it works. But as you can see, it is quite a behemoth to be able to download these files. So we're calling it listen for latest audio. And so what this will do is listen for the latest audio file in the messages collection. So it takes a account reference, so a document reference. So it's just a reference to the account document within Firestore. And then it also accepts a parameter, which is an on new audio. And that's kind of like a file point or function pointer. So it's really giving this method the ability to call another method or function. And what it will do is it will call it and pass it a URL. And you need this escaping decorator to allow it to escape this operation. But yeah, so it passes the URL, and that's the URL of the audio file to play. And so within this method, we're going to define the self.audio listener. So this is this audio listener that we created just a second ago. And we're going to say it's equal to the account ref dot collection message. So this is the messages collection, and it's going to order the messages collection by time and descending time and limit it to 1. And all of this right here pretty much just says the most recent one and don't care about everything else. And so that makes it more efficient, and it makes it so that it's not grabbing every single message and listening to every single message. We only care about the most recent message. And then so we're going to add a snapshot listener to this message, this most recent message document. And so that will give us a function, and it will and it will pass us the query snapshot and an error. So we're going to take that query snapshot and we're actually going to iterate for each of all the different document changes. And so for that gives us a difference. So it's the difference between the document, and we're going to check the difference type of this message document, and we're going to check to see if it's modified. And you can see we don't do anything if it is any other scenario. So really what we're doing is we're trying to pick out when the audio field, this audio field here, appears. And that audio field is going to appear once the audio file is completely added into the storage. So this functionality right here in this section will only be executed for the most recent message and only when it is modified. Okay, so we're going to take this chunk of code, this pile of code right here. What it does is it grabs that most recent message out of the query snapshot, and it's just a bunch of code to decode it effectively as a message. And then we're just checking to see if we actually got a message out of all that junk. And so finally we actually have the message. So this code here is going to execute with the message. And then we're going to say if audio is equal to message.audio. So that's pretty much saying if the message has an audio field. So now that we have the audio field of this latest message that was just changed, you can see we've kind of created this trigger that will only execute when the audio field is added. We're going to grab a storage reference. So this is just getting ready to work with the cloud Firestore. Yeah. And then we're going to create a temporary file name. So this temporary file name will be based on the message ID, and we're going to append to it MP3. So that just gives us like a unique file. And then we're going to specify the temporary directory URL. So this URL is going to be the temporary directory. And one big thing is, we're working just like when we were recording the audio, we're working with like a temporary directory. And so it will be cleaned up and managed automatically. Then we're just creating the overall file path. And then we're creating a downloading task. So we take the storage reference and then we specify the child, which is going to be the audio. And so this audio field is actually the URL within the storage. And then we will write that storage reference, that data from this URL that's part of the message to the path locally on the iOS device. And so once we've created this download task, we're going to observe it. And when the success trigger activates, we're going to call the on new audio. So that pretty much says, okay, when the file is completely downloaded onto the device, let's call this parameter on new audio with the path. Okay. And then finally, we're going to add a bit of error handling here to observe failure, and we try to print the localized description. This is just boilerplate that's part of the guides for Firebase storage, but definitely do better error handling in a larger project. But in this case, we're just flushing out the main functionality. Okay, so this will allow us to listen for the latest audio and then call this on new audio function when we have a new audio completely downloaded. Cool. So now let's work. So now we have the message view model handled. Let's work on the voice view model. So within the voice view model, we're going to have to add a couple things. So first, we're going to upgrade the voice view model to be a NS object and a AV audio player delegate. So this is necessary because the AV audio player is actually going to call this voice view model as a delegate and let us know when the audio is done playing. So one thing we're going to have to do because of this is we're going to have to override instead of just init. And then we're also going to define the player. So we have the recorder, and we're also going to have a player. And then we're going to also define a new published variable, which is playing. So pretty straightforward. If we're playing, set that to true. Okay. So next, we're going to change the update audio levels. So previously it just updated the audio levels of the recorder, but we also want to update the audio levels of the player. And fortunately, it's the exact same kind of interface. So we're just going to, if let player is equal to player, it's like the same thing, but just with the player instead of the recorder. Okay. And then we're going to define a new function for this, or a new method. And that method is going to be called start playing. So this start playing is going to be called from the message view model that we just created, that new function. So we'll be calling the start playing when we have a new audio file. So first we're going to define the player. And so we're going to try to create a AV audio player, and the contents of that audio player will be the path, which will be what we just downloaded. We're going to set the delegate to self, so that allows the player to call this class, and we'll be defining a method for that to call. And then we're going to say is the player's metering enabled, so that allows us to capture the audio levels of the audio file as it plays. Next, we're going to say, okay, start playing the audio. And we're going to say is playing equals true. So that is going to set this published variable, and our UI can react to that. Okay, next we're going to define the stop playing. So we can start playing, we can also stop playing. And that's just as simple as saying is playing is equal to false. And then, and actually, I think we should probably also add player dot stop and player equals nil. Okay. Next, we're going to define audio player did finish playing, and this is part of the AV audio player delegate protocol. And so what it's going to do is it passes us the player and successfully. And so we can say, okay, we're going to say set is playing equals false. So when it finished playing, we're going to say set is playing is equal to false. And we're going to set self.player is equal to nil. Okay, so all of this is going to allow us to play the audio using the voice view model. Now, finally, we want to tie everything together in the voice view. So you can see here, we've done all the kind of backend within the app of the message view model and the voice view model, but we haven't connected these two models together and connected them to the user interface. So let's go ahead and do that within the voice view. So in the voice view, we are going to add a couple things. So first, we are going to add, so previously we were just showing the waveform view if it's recording, but we also want to show it if we are playing. So voice view model dot is playing. So this is saying, okay, show it if it's recording or if it's playing. And then the author still works. So that's going to, if it's playing, it's going to be false. And that is going to handle all that. If audio level, button spacer. Okay, and then the last thing we're going to do to this is on the overall H stack, we're going to subscribe on appear. So when this overall H stack appears, we're going to say message view model dot listen for latest audio. So we're calling this method that we just created. The account ref is going to be account ref, which is pretty simple. And the on new audio, we're going to define that. So let's use closure. And so audio in. So this is that escaping function that we created before. And so when we get a new audio file and when it's all downloaded and ready to go, we're going to say voice view model dot start playing. And we're going to give it the path, which is audio. So it's kind of simple. We're tying the message view model to the voice view model within the voice view. All right, so let's go ahead and give this a shot and see what happens. Okay, so it built correctly. Now let's try talking to it. I think you can speak back to me now, but I'm not 100% sure. So our cloud functions should be running, but I'm not 100% sure. Look, so it transcribed it correctly. Now let's see if it can generate a response as a comedian.
Well, let's hope I'm more reliable than your phone's battery at 1% when you're expecting a call from your crush.
Cool. Well, look at that. It responded with audio. So let's try one more thing. That's a joke because I would never expect a call from my crush.
Then it's a good thing I'm already here to sweet talk you with my punchlines. No dialing.
Damn, it thinks it's my crush. That's really great. Awesome. Well, we're able to speak to the app, and hopefully you're able to speak to your app and create something really powerful with this. This concludes the tutorial on how to speak to your iOS chat app. We connected SwiftUI, Firebase, Python, and Google Cloud Speech, all to laugh a little bit. I hope you create something incredible that helps thousands of people. Try out APZ8, the free journal app for iPhone. It asks you questions, celebrates your accomplishments, and generates AI art. You can try it from the link in the description. Thank you and have a great day.